Good morning. Welcome to the Museum of the San Ramon Valley's virtual speaker series. I am Dan Dunn, the director of the museum. We're over a year and a half into the programs in this series. Past presentations have included California's first people, then and now, the Sunol Water Temple, and last month, the history of Alamo. We hope that you've enjoyed this speaker series. We have driven through it, been stuck in traffic by it, and wondered at its construction. Today, we're happy to have historians and authors of the book, Building the Caldecott Tunnel, Mary McCosker and Mary Solon, as this month's presenters. They will tell us the story of the Caldecott Tunnel, that's such a critical connecting point so that traffic and commerce can negotiate the Berkeley Hills. Please use the chat window at the bottom of the screen for any questions that you have. Feel free to send in questions at any time during the presentation, and we'll address them at the end. And now it's my great pleasure to introduce Mary McCosker and Mary Solon.
Before the Mexicans, the Spanish, and the Yankee settlers arrived in the East Bay, the native people followed paths and trails over the hills between present-day Alameda and Contra Costa counties. These paths generally followed the stream and creek beds of the area. Natives used the trails for hunting, gathering plants, and trading with other tribes of the East Bay and Marin County. Early settlers on horseback or with horse-drawn wagons or buggies used trails and primitive roads to cross the hills. Although the first roads were little more than dirt trails, Contra Costa County was divided into road districts as early as July of 1850. And a few main roads were declared public highways. Once roads had been established, people could travel more frequently between the counties. Farmers from Contra Costa County brought their agricultural goods to Alameda County to sell at the produce marts. For years, crossing over the hills using Fish Ranch Road was possible only on foot, on horseback, or using a horse-drawn carriage. The road was so steep, winding, and often rutted that horses had to be led or pushed to reach the summit. In 1859, the Alta Telegraph Company constructed a telegraph line between Oakland and Martinez, and the existing road that ran alongside it was renamed Telegraph Road. The segment of the road that ran from downtown Oakland to the Peralta Estate in Temescal was first known as Peralta Road. The road from Berkeley followed the present-day Telegraph Avenue and connected with Claremont Avenue, and then went over the hills following the approximate path of today's Fish Ranch Road. In this January 1904 photo, Vic Post and C. Air stand by the Oak Springs Creek, located along Fish Ranch Road. The road was often impassable in winter months when the creek would overflow its banks. Farmers of Contra Costa County used horses and wagons to carry their products over the hills to sell in Alameda County. In this 1880s photograph, horses and wagons parked at the Oakland Produce Mart on 11th Street, north of Broadway, and they're ready to load produce to deliver to local neighborhoods. Summit House was a stopping place that stood at the top of Fish Ranch Road in the late 1880s. Those traveling between Alameda and Contra Costa counties could stop here to change horses, have a meal, or spend the night. In the late 1880s, trips over the hills went up Claremont Avenue to the summit. After the long climb, the downgrade to the east ended at the Oakland Trout Company, where there was a small saloon, large stables, and a stage stop near the road. The road became known as Fish Ranch Road because of the fish and frog farm located there. There was an interest in building a tunnel between the two counties as early as 1860, but the idea was initially rejected by citizens of both counties. The project would be too costly, and a route could not be agreed on, so these initial efforts to build a tunnel were abandoned. The idea of digging a tunnel was revived in the 1890s when money from the two counties and funding from private citizens financed a new tunnel. The route would run from the end of Broadway, following the route of today's Caldecott Tunnel. The proposed tunnel would be about 500 feet long and would exit on the southern side of the San Pablo Creek watershed with a road leading into Lafayette. A franchise was granted to a group of developers who passed the franchise on to another group. The proposal stalled until the turn of the century. In 1903, a tunnel was built above the current location of the Caldecott Tunnel in the next canyon south of Claremont Canyon. This tunnel was approached by a new road called Tunnel Road, which started at the top of Ashby Avenue in Berkeley. The tunnel was called the Broadway Tunnel for the road that accessed it, or the Kennedy Tunnel for the old toll road and the local farm near the West Portal. It was located 320 feet below the summit and was 1,040 feet long, 17 feet wide, and built with timber supports. It could barely accommodate two-way traffic. William Buckley's house was located near Tunnel Road on the east side of the tunnel. A barbecue was held here in May 1897, attended by representatives from Alameda and Contra Costa counties. Subscriptions were sold to fund the construction of a new tunnel. The house was torn down in 1935 to make room for the east portal of the Broadway low-level tunnel. Local families set up camps at the Buckley Ranch so the men could work on the construction of the tunnel. Robert McNeil from Lafayette worked on the tunnel, and his wife Gertrude, shown on the back left, is said to be the first woman to pass through the tunnel 2 days before its completion. Work on the approach and entrance to the tunnel is shown in this photo. The cost of construction was to be shared by both counties. But when a survey showed that 3/5 of the work was to be in Contra Costa County, Alameda County refused to pay for work that was not in its jurisdiction. The Merchant Exchange of Oakland raised the needed $15,000 so the project could continue. Workers had to climb steep hills to the tunnel site, where they excavated using picks and shovels. Horses pulled carts on rails to haul out the dirt. Day laborers did the work on the Contra Costa County side. Alameda County hired a contractor to do the work. Opening ceremonies for the tunnel were attended by dignitaries from both counties. Although the bore had been completed, the tunnel was unpaved, unlit, and prone to mudslides. Officials and guests gathered at Idora Park, a 17.5-acre park on the north banks of Temescal Creek in Oakland, to witness literary exercises held in the presence of a large audience. There, the tunnel was formally turned over to the supervisors of Alameda and Contra Costa counties. The approaches to the tunnel, Old Tunnel Road to the west and Fish Ranch Road to the east, involve steep roads with many hairpin turns and dangerous cliffs, making the route difficult for 4- and 6-horse teams to traverse. Large hay wagons, which could carry as much as 2 tons of hay, were sometimes too tall or wide for two-way traffic traveling through the tunnel. Drivers on either end of the tunnel would light rolled up newspapers or hold up lanterns to signal drivers on the other end to wait for them to pass through. The west portal of the tunnel is shown in this 1920s photo. Electricity became available in 1914 and lights were installed in the tunnel, while light poles were added outside. Workers changed light bulbs by standing atop hay wagons as they traveled through the tunnel. There was a $300 surplus from the money raised by subscriptions for the construction of the tunnel. All attempts to spend it on anything else were blocked, so the money sat in a trust fund for 30 years and grew to $900. The money was used to purchase a triangular plot of ground in front of the Oakland portal, upon which a flagpole and a marker were erected. This building, located on Henry Buckley's property near the east portal of the tunnel, provided a place to stop for food or fuel. When Frank Enos purchased the property in 1918, he convinced the Shell Oil Company to paint the buildings yellow when it was repainting the gas pumps, giving the place its nickname, Canary Cottage. In this February 1929 photo, huge icicles are shown hanging from the roof of the Kennedy Tunnel. Thousands of motorists were amazed by the 3- and 4-foot icicles created by seepage from the roof. Many people broke them off and carried them home. After the installation of electric lights in the tunnel in 1914, Frank Enos made a deal with the power company and tended the lights in the tunnel in exchange for the lights at the Canary Cottage. The walls of the tunnel were initially whitewashed for improved visibility. Ernest Guido, secretary of the Oakland Motorcycle Club, is shown on his Harley-Davidson motorcycle at the Kennedy Tunnel in 1917. 2 months before this photo was taken, the United States entered World War I. Corporal Guido was drafted and served in France, where he was killed in action at the front in September 1918. This original marker for the Kennedy Tunnel was located near the West Portal. By the early 1930s, more than 4,000 vehicles traveled through the narrow tunnel each day on a faster and safer route between Alameda and Contra Costa counties that offered easier access to San Francisco. The last remaining piece of the Kennedy Tunnel is this marker, located near Tunnel Road, close to the West Portal, above the current Caldecott Tunnel. The old tunnel was closed to traffic in 1937 and used to store munitions during World War II. It collapsed in 1948 and was filled in to provide for public safety.
By the mid-1920s, the Kennedy Tunnel had improved access between Alameda and Contra Costa counties, but travel was difficult due to the tunnel's steep approaches and narrow width. In 1926, Alameda County, Contra Costa County, and the city of Oakland formed a joint commission to study the idea of moving the tunnel to a lower elevation. By 1929, the two counties had organized the Joint Highway District number 13, which also is the number of the road in the Oakland Hills, to build the Broadway low-level tunnel. Several individuals were important in organizing the district. Thomas Caldecott, Alameda County Supervisor and President of the Joint Highway District number 13, George Posey, County Surveyor in Alameda and Chief Engineer for Joint Highway District number 13, who is best remembered for designing the tunnel between Oakland and Alameda, the Posey Tunnel, and Henry Myers, Alameda County architect. The original approaches to the tunnel were to extend from Broadway in Oakland to Walnut Creek. In 1931, the district decided not to build the Contra Costa County approach, but it still had to design and build 2.82 miles of roadway, 0.6 miles of which was in the tunnel. The project cost $3.75 million to $1.1 million, came from a grant from the Public Works Administration, $700,000 from state gasoline tax money, and the remaining amount from local sources. The successful bid came from 6 companies of California, which began construction in late 1934, but was unable to complete the job. With 68% of the work completed, the job was advertised again, and the George Pollock Company successfully won the bid to complete the tunnel lining, along with Smith's 6 smaller contracts for paving the road, building the ceiling for the tunnel, installing ventilation and electrical systems, and finishing the detail work on the portal buildings. Formally opened and was turned over to the California Division of Highways on November 13th, 1937. Its completion coincided with the opening of the San Francisco Oakland Bay Bridge, which provided a more direct and convenient commute by automobile from Contra Costa County to Oakland and San Francisco. By June 1928, the Joint Tunnel Engineering Commission of Alameda and Contra Costa had narrowed the choice of new tunnel sites to two: the Temescal Creek route near the Kennedy Tunnel and the Shepherd Canyon Toll Road along Park Boulevard to Moraga Valley. The Temescal Creek route was chosen. Other proposed routes and tunnels were rejected because of excessive grades and the prohibitive length of the tunnels. On the recommendation of Charles Durluth Jr., a civil and consulting engineer at UC Berkeley, the proposed tunnel would consist of twin horseshoe-shaped bores that each provided 2 lanes. The Broadway low-level tunnel was initially financed by a bond issue of Joint Highway District Number 13 in the amount of $2.378 million to be paid in allotments from gas tax money allocated to Alameda and Contra Costa counties. Alameda was to pay 90% of this amount and Contra Costa 10%. The state made a grant of $300,000 to the Joint Highway District and later gave an additional $400,000. The Public Works Administration provided a grant of $1.95 million to complete the project. Groundbreaking ceremonies were held on June 17, 1934. A crowd of 6,500 people saw Governor Frank F. Merriam, Senator, assisted by Earl Lee Kelly, the State Director of Public Works, on the left, and Alameda County Supervisor Thomas E. Caldecott, Chairman of Joint Highway District Number 13. Although President Roosevelt was listed in the event program as a guest of honor, he was not in attendance. This project was one of the first major projects of the Public Works Administration of the New Deal and provided employment for many out-of-work men in the Depression. This first phase of construction involved clearing the hillside and grading, shown here on the Oakland side. The Kennedy Tunnel and the original roads leading to it are visible in the upper part of the photograph. The lower location of the new tunnel meant a shorter climb, but a greater distance for construction workers to bore. This is one of our favorite photographs. Jim Silva, shown on the right, tried to find employment on the tunnel project only to be repeatedly turned down and told that Irish miners were preferred. He went to City Hall in Oakland, legally changed his name to Sullivan, and was soon hired on the project. Silva's brother-in-law is shown on the left. He's in dark clothing, and his brother is in the middle. Edgar Baugh was a foreman on the tunnel project and got us this photograph. He's second from the left at the back near the entrance to the tunnel portal. He had worked on water tunnel construction, had been buried alive in a cave-in. It took him more than a month to recover. Work bridges called jumbos were used in tunnel construction. They were run on tracks into both bores. This scaffolding was used to support the excavation. Wood timbers, metal ribs, and laggings were used to prepare for the installation of steel forms around which the concrete lining was poured. The pipe shown on the right side of the photo on the left is used to pump fresh air into the tunnel. I didn't do that. This cross-section of the tunnel shows the type of steel form liner used to apply the concrete to the tunnel arch and a concrete jumbo structure shown inside of it. The concrete was pumped on the form and hand troweled. On August 28, 1935, the north bore of the tunnel caved in near the western portal. killing 3 men. The contractor, 6 companies at the time, had notified the district of Joint Highway District number 13 that it thought the tunnel design was faulty because of the instability of the ground being tunneled. An aerial photograph looking north across the canyon to Tunnel Road shows the hole caused by the downgrade tunnel cave-in. This sink, 100 feet in circumference and 15 feet deep on the hillside, 90 feet above the cave-in, indicated a complete collapse of the bore. Cars on the tracks delivered concrete from the mixing plant to the inside of the tunnel where it was sprayed on the walls to reinforce excavation. Over 120,000 barrels of concrete, 2,500 tons of reinforcing steel, and 1,000 tons of structural steel frames were used in construction. More than 700,000 square yards of 8-inch oiled macadam pavement was used to complete the job. Overhead louvers that prevented sunlight from falling on the roadway were constructed at the approaches between the portal walls of the tunnel to allow eyes to adjust to the transition between the artificial lighting in the tunnels and the direct sunlight outside. The main part of the project was 2 parallel concrete-lined tunnels, each about 3,000 feet long, one for eastbound travel and the other for westbound. Each had a 22-foot roadway with 2 traffic lanes and a 3-foot sidewalk. Both ends had 4-lane approaches. This photo taken before the tunnel was open shows an automobile driving in the wrong direction. I would like to mention that it's kind of confusing sometimes to think about the numbered tunnels. So here's how you remember. If you're standing in Orinda and you read from left to right, 1, 2, 3, 4, from Orinda looking at the tunnel, the first bore is on the left, the second bore is second from left, etc. And of course, everybody knows where the 4th bore is. Thousands of people lined the hill at the west portal to witness the dedication ceremony on December 5th, 1937. More than 10,000 motorists backed up to Broadway and College Avenues and awaited the signal that opened the new bores linking the 2 counties. And as you can see in this photo, they have the bore covered with bricks, lined with bricks, which of course were fault and then were foam or something, and then they opened the tunnel. Alameda County Supervisor Thomas Caldecott, and on the left center, and Governor of California Frank Merriam were among the dignitaries who attended the tunnel dedication after a breakfast at the Claremont Hotel. Following the speeches at the East Portal, more than 4,000 motorists drove through the tunnel in the first hour it was open. Nancy Borgeson was the first baby to ride through the Broadway low-level tunnel. In 1903, her grandmother, Gertrude McNeil, had been the first woman to drive through the Kennedy Tunnel. We saw her before. Nancy is shown with her mother, Bertha Borgeson, youngest daughter of Gertrude and Robert McNeil of Lafayette. Henry H. Myers, the architect for Joint Highway District number 13, designed both the portal buildings and the approaches. He had worked with George Posey on the Posey Tube, where he first used Art Deco ornamentation on the tube's portal buildings. Decorative detailing on the Broadway low-level tunnel is shown on the reinforced concrete medallions and other parts of the tunnel. The same 4 medallions appear on the faces of the 2 tunnel portals. The medallion on the left shows a car exiting the tunnel, and the eagle on the right was visible on the face of the eastern tunnel portals. With the opening of the Broadway low-level tunnel, hundreds of East Bay residents purchased property in Contra Costa County. Oakland realtor Fred Wood reported that he sold 7 home sites in his Moraga Woodlands development in one day. In 1938, half-acre to 5-acre lots were available at a beginning price of $1,000.
In the post-war era of the 1950s, the state had made improvements to Highway 75, later to be renumbered Highway 24, at the approach to the Broadway low-level tunnel that changed it from a 2-lane road to a 4-lane freeway. As the population of the cities east of the tunnel increased, so did the number of automobiles using the tunnel. Construction on a third bore began in November 1961, about 150 feet north of the second bore of the original tunnel. This bore was designed to be larger than the 2 preceding tunnels. The state made sure there was ample land available should a 4th bore need to be constructed in the future. Scientific advances and information from the construction of the original bores were available to aid in the construction of the 3rd bore. The 3rd bore was completed in October 1964. It was approximately 300 feet lower than the existing Kennedy Tunnel and built on a 4% grade descending from the Orinda end towards Oakland. Both ends were built on curves in order to provide a smooth transition into the approaches at each end. The new tunnel had a 28-foot roadway with a 4-foot sidewalk to the right of traffic and a 2.5-foot curb on the left with 17 feet of vertical clearance. The 3rd bore cost nearly $25 million, more than twice the cost of the original 2 bores. After the 3rd bore opened in 1964, the 2 original bores were each separately closed for needed maintenance, which included installing fluorescent overhead lighting. The middle bore was then used to accommodate commute direction traffic in the mornings and evenings. Pop-up barriers were added when the center bore's direction was changed. By 1958, the state of California had approved an 8-lane freeway from the East Shore Freeway to the Broadway low-level tunnel. The Grove-Shafter Freeway was to be 6 miles in length and would help to accommodate traffic loads, which were estimated to increase to more than 54,000 vehicles per day in the 1960s. This 1959 image shows a cross-section of the proposed 3rd bore that reveals the changes made since the construction of the initial 2 bores of the tunnel. The roadway is wider with additional space on the sides of the lanes. The height of the bore itself, as well as the ceiling height, is bigger to accommodate taller vehicles, and the ventilation system has been improved. The power plant that supplied the electricity for the construction was located near the western portal. Electricity supplied by PG&E ran compressors to furnish air to pneumatic drills, huge shovels, concrete mixers and saws, and charged batteries for the cars that hauled equipment. The first phase of the tunneling operation consisted of placing 3 small shafts or drifts in the mountain. Ventilation through large pipes was needed to provide fresh air and to remove explosive gases such as methane and other noxious gases, including blast fumes. Small cross tunnels called adits connect the main tunnels at 3 locations between the portals. These were used for additional safety during construction and for tunnel maintenance and emergency operations. 3 adits connect the 2nd bore to the 3rd bore. More than 100,000 tons of concrete were poured into the 3rd bore. It took 9 months to pour the arched roof, the sides, the roadway, and the ceiling of the 3,300-foot-long bore. Contractors leased special concrete holding equipment, shown in the photo on the right, and guns to pour the arched roof and walls of the tunnel. After the construction of the tunnel was complete, the walls and ceilings of the 3rd bore were tiled with 5 acres of seafoam green tiles. The previous 2 bores of the tunnel had not been tiled due to cost. There is a painted line on the wall of the 3rd bore showing the dividing line between the 2 counties, but be careful if you are looking for it while driving through the tunnel. Also notice that part of the roadway in bore 3 is bumpy to drive over, but partway through the surface becomes smoother. On August 18th, 1960, the Broadway low-level tunnel was renamed the Caldecott Tunnel, honoring Thomas E. Caldecott, who played a major role in the planning and implementation of the tunnel. His widow is shown cutting the tape. The other family members attended as well, including his grandson, Thomas P. Caldecott. Just after midnight on April 7th, 1982, a westbound driver lost control of her car and struck the tunnel wall in the third bore. When she got out to inspect the damage, traffic in the bore slowed. A tanker truck carrying gasoline and traveling at a high speed struck the car. An empty bus following the truck hit the car and the tanker. The bus driver was ejected from his vehicle and killed, and the bus continued along in the tunnel and crashed near the exit portal. The tanker was leaking gasoline and was unable to move. Small fires started around the leaks. The driver was able to escape, but gasoline continued to escape into the drainage system. The downgrade of the tunnel caused the smoke to flow uphill toward oncoming vehicles. About 20 vehicles were able to get out of the bore, but 4 vehicles were left trapped behind the burning tanker. 2 people died in the initial crash, 5 were killed by smoke and fire, and 2 suffered from smoke inhalation. The fire raged for over a half hour, burning about 8,700 gallons of gasoline. Some of the spilled gasoline drained into Lake Temescal, and the fire department was deployed to be sure that a fire wasn't ignited there. The temperature in the tunnel was estimated to have reached over 1,800 degrees Fahrenheit. The tiles and grout in the tunnel were damaged by the intense heat. The tunnel was closed for repairs for several months.
In 1998, the Metropolitan Transportation Commission, in cooperation with the Alameda County Congestion Management Agency and the Contra Costa Transportation Agency and Caltrans, decided to study what could be done to alleviate traffic congestion, which had continued to increase on Highway 24 since the opening of the Caldecott third bore in 1964. One option to be looked at would be to build another tunnel bore through the hills. It was eventually determined that adding a 4th bore would help existing and future reverse commute traffic, eastbound in the morning and westbound in the afternoon, and weekend traffic congestion at the tunnel. Funding for the project would come from a number of sources. $420 million was initially projected as the cost for the Caldecott 4th bore project, which included the construction of the 4th bore, realignment of the westbound State Route 24 to the northbound State Route 13, K Street improvements and landscaping. Construction contracts were awarded and excavation of the 4th bore began in August 2010 on the westbound side. This German-built Wirth road header, WIRTH, was shipped from Europe to the Port of Oakland by the way of the Panama Canal. It was able to excavate more rapidly and safely than many miners working by hand. The road header excavated from the Orinda or eastern side. A small road header worked from the Oakland or western side. Excavation progressed about 6 feet a day, with workers reinforcing the walls before moving forward. The length of the excavated section was based on the surrounding geology. The harder the rock, the farther excavation could progress before support was needed. The 4th bore was excavated from both the Orinda and Oakland sides, with the excavation on the eastern side beginning in August of 2010. About 3/4 of the tunnel was excavated from the Orinda side because the Orinda and Claremont geologic formations were more stable than the Sobrante formation. The Western Oakland side excavation began in March 2011. Workers from Tudor, Saliba, Caltrans, and other subcontractors were required to use the brass board, a vestige of the mining industry, at the eastern portal. There was a tag board at the entrance to the tunnel. The board was used to indicate who was in the bore. Every time a worker went into the tunnel, he had to tag in or brass in by placing a brass tag with his name stamped on it on the inside of the tag board. When leaving the mine, he tagged out or brassed out by moving his brass to the outside of the board. Brass tags were used because brass has a very high melting point, and in the event of a catastrophic fire inside the tunnel during construction, the brass tags would identify the workers. The strength of the tunnel roof was tested after shotcrete, a fast drying concrete, had been sprayed on the walls and had hardened. After excavation, shotcrete was applied to walls and steel rods were installed around the perimeter of the excavation. The shotcrete and steel rod provided temporary support during construction. The portal walls were set back into the hillside, so retaining walls needed to be built perpendicular to each portal wall to hold back the hillside. These walls were tieback walls, which were built on the exterior of the hillside. Holes were drilled into the hillside, steel strands were inserted, grout was injected into each hole and allowed to harden. The strands and bearing plates protruded through the face of the wall and were tightened, pulling the wall against the hillside. The upper portion of the crown of the tunnel was excavated first before the bench, the middle portion of the tunnel, and the invert, the lower portion of the tunnel. Near the western portal, all that remains to be excavated is the bench. Tunneling from the west presented difficult challenges than from the east. The less stable rock formation required the installation of structural reinforcements at shorter intervals than on the eastern side. Different excavation equipment was also used on this side. After a section had been tunneled, front-end loaders moved the tunnel spoils to long, flat mining dump trucks. The trucks offloaded the spoils outside the tunnel portal. All spoils were tested for contaminated materials. Loaders filled larger dump trucks with clean spoils that were off-hauled to Treasure Island in San Francisco. Any contaminated spoils were loaded into trucks and transported to appropriate disposal sites. All tunnel spoils were tested for hazardous materials before leaving the site. Naturally occurring hydrocarbons would be the most likely hazardous material if any were found. Paleontology samples were sent to the University of California, Berkeley for analysis. 7 millimeters of yellow waterproofing membrane made of a polymer-based material was applied over the top of the smoothed shotcrete that had been applied along the length of the tunnel. Workers used metal twist ties to fasten pieces of rebar that provided reinforcement and strength to support the final concrete lining. Over 3.5 million tons of steel rebar were used in constructing the fourth bore, which will enable the tunnel to withstand a strong earthquake on the Hayward Fault. Concrete was applied to the outside of the tunnel to create the portal entrance. Once the tunnel excavation had been completed, work on the outside and inside of the bores progressed. On the outside, movable work bridges were an improvement over the jumbos used in the original Broadway low-level tunnel construction. Stainless steel panels were installed along the entire length of the tunnel. Designed to be easily cleaned, the panels also help to focus the motorist's attention on the road ahead. Tunnel workers lay concrete to complete the roadways and curbs in the new bore. Rebar was placed in the road beds to increase its strength. The new bore has a 10-foot shoulder on the right and a 2-foot shoulder and 3-foot walkway on the left. 19 jet fans were installed in June of 2013 to remove smoke from the tunnel in the event of a fire. They can be operated manually or automatically and can direct airflow in either direction in the event of emergency. We wanted to make a reference in our book to the face that's painted on the front of the fan cover. Looks like Thomas the Train, but our publisher said no. A new operations and maintenance control building was constructed, which is the nerve center for the 4 Caldecott tunnels, as well as the Webster Posey Tube in Alameda County. The operations and maintenance control building is staffed 24 hours a day, 7 days a week by specially trained operators. The 4th Bore project sponsored a contest for Alameda and Contra Costa County students to design a medallion for the new tunnel portals in the Art Deco style. The winning designs are from Alameda County on the left-hand column and Contra Costa County on the right. The ribbon cutting ceremony signaled the completion of the 4th bore. Speeches were given, medallions were unveiled, and thanks were given to those who made this project a success, coming in on time and under budget. The tunnel was officially opened to traffic on Saturday, November 16th, 2013 at 4:25 a.m. The 4th bore has recently been named after Ellen Tauscher, longtime congressional representative for our local district. The Caldecott bores are numbered from left to right and from the Orinda side, with the original bores 1 and 2 on the left and the newer bores 3 and 4 on the right. Thomas P. Caldecott holds a photograph of his family taken at the naming of the Caldecott Tunnel after his grandfather, Thomas E. Caldecott, in 1960. The shovel and pail were given to his grandfather at the groundbreaking of the Broadway low-level tunnel in 1934. 2013 was a year of major milestones for San Francisco Bay Area commuters, with the opening of the new span of the San Francisco-Oakland Bay Bridge in August and the 4th bore of the Caldecott Tunnel in November. Driving times between Contra County in the east and Alameda and San Francisco counties to the west were shortened. Much like the openings of the Bay Bridge in 1936 and the original Caldecott bores in 1937, the 2013 transit improvements continue to make the towns and cities east of the Oakland-Berkeley Hills more available to travel and living, a far cry from the early wagon trips over the winding dirt roads. So there you have it. Thank you for having us. We really enjoyed being here today. And we, as does your museum, have a book out on it, on the tunnel, called Building the Caldecott Tunnel.
Okay. Oh, excuse me. Thanks, Mary and Mary. And a couple questions. First of all, you've got some fans. Lou wanted to compliment you that he had lived in Contra Costa County for 50 years and didn't know any of this. So that's one. And then Terry wanted to compliment you, and this one came in early in the presentation, so I think it was the older photographs. But he wanted to compliment you on your research and the great photos, and wondered, how did you do your research for that early period and find those great photos?
Well, Caltrans has an office in Oakland, so they were very helpful and didn't charge us for the use of their pictures. The Oakland Museum of California had some. We went up to the Transportation Museum in Sacramento, where they had some local historical societies, Orinda, Moraga, and we had some here. Contra Costa Historical Society.
Yeah.
And can you remember any others?
I think you found some online.
Yeah.
But the really nice thing about it was, if we had been publishing this book for profit, we wouldn't have gotten the cooperation, but we said we're donating all the funds to the Lafayette Historical Society. And so people really just opened the drawers of all the cabinets and so
Good for them.
yeah.
Oh, and
So-
then, never mind.
So since you mentioned the book, and I know you put the slide up, but can you go over one more time how people can get a hold of that book for fans like Lou and Terry?
If you go to LafayetteHistory.org, that's our website. You should be able to find a place where you can purchase the book. You can send us a check in the mail. It has our address for the book. We don't charge tax, so it's just, I think it's $22. I will deliver them if you're local. You can also pay through PayPal, and that will tell you how on the website.
Okay. And I was wondering this one, and Ken and Leslie actually asked the question. So from going back to those original trips, how long might a wagon have taken to go from Walnut Creek to a market in Oakland?
Boy,
Wow.
would have
I
taken
mean,
a bit,
that's a distance, and when you start to factor in the terrain,
right? I mean, think of it was just a dirt road from Walnut Creek all the way to the Oakland Hills. I would guess it might have, well, if they were taking things early in the morning, I don't know, it might have taken a whole day.
Yeah.
yeah,
I would guess. Yeah.
That
and
is
with
if you're
that might help explain the lodging house at the top of the
right,
trail, right?
right.
Well, and there's also weather, of course, like rain or something,
Yeah, yeah. Okay. Thomas the Train Face on the jet fan. Your publisher wouldn't let you put it in the book, but why is that face there?
We don't know.
No.
Maybe somebody had a sense of humor.
Yeah, we
Okay.
think that.
Somebody
Yeah,
on
we
the construction
yeah.
crew.
All right.
and also kind of on a similar vein, we were told, but we never found anything in writing, that the men that were building the tunnel had a pool going as to when there would be a tunnel breakthrough. We didn't put a picture in, but there's a real nice picture of the third tunnel and the man coming through, and then somebody wins a big pot of money like any football pool.
That's not surprising. There was a rumor that's popped up in a question of a bandit hanging out at the Orinda portal.
I'm sure there must have been
There were
somebody.
holdups. We've
Yeah.
read about holdups
Okay.
in the paper. Yeah, I don't know if there was one particular person.
Opportunist.
Yeah, build a tunnel and they will come. You mentioned the roadway in the third bore being partly bumpy and partly smooth. Why the difference?
Okay, that is because what we were told was once the road starts getting smooth, that you are out of the Orinda, what's it called?
Sobrante or the Orinda portal?
The Orinda, not the portal, but the geologic structure.
Sobrante.
Yeah, was it Sobrante?
I think so.
Oh gosh,
So
senior moment.
it's just the difference in the geology
Yeah.
of the bore.
Okay.
And also,
ahead.
if you saw those icicles, when you go through the first two bores, coming from Oakland to Orinda, there during the rainy season, you will get drips on your car. It just the water, not a stream or anything, but drips. So we haven't seen. I've never seen icicles, but could be.
I found it rather alarming, those people standing under those 3 and 4 foot icicles You're braver than me. I wouldn't do that. You mentioned the projected cost of the fourth bore was, or the projected cost was 420 million. What was the actual cost? Because it came in under budget.
Wow.
I can't imagine it came in too much under budget, but it
Yeah.
didn't exceed the budget, which in this time period, this
sure.
day and age, is a really big thing. They always have cost overrides and things, but that was a point of pride and very much mentioned at the opening.
It was cool seeing the two photographs of the two Caldecotts, granddad and grandson. That's a great pairing.
Go ahead.
I
tell them that story.
forgot how we got in touch. How did we get in touch with
I don't
him?
know. I think we heard somebody that there was a Caldecott, and I think his aunt said that it's not Caldecott, it's Caldecott. She was
Right.
Scottish.
Yeah. But he was really nice and
Great guy.
cooperative. Yep.
Yeah, we had a lecture and he came in and talked. Yeah.
That's very cool. I can answer this one. Vince had worked for the company that designed the fourth bore and was asking for a copy of this. And as I said earlier, this will appear, I'll tell you in a minute, but this will appear on the museum's website probably early next week. So Vince, that's where you can go find a copy of this for you. That's all the questions that I've got. Oh, wait a minute. One just came in. What got you two interested in this subject? And what was your favorite aspect? I think this is a good question. What was your favorite aspect of doing the research for the book?
Well, we're both history buffs. And so when, there was a lot of publicity initially about when they decided to begin the process of building the fourth bore. And we thought it would be interesting to sort of look at it. And then because we like history, and then we kind of we'd done a book on Lafayette. So we decided, well, let's do a book on all of these tunnels, because nowadays you think of the Caldecott, but what preceded it? I think I like the old parts better. I mean, I can only imagine what it must have been like. And I go into Berkeley often because I'm on a board at Cal, and I go over the Fish Ranch Road all the time. And there's that picture of the two men standing by the creek. And I think about it every time I drive along the creek on Fish Ranch Road. So the old part, the history, is what really got me.
I think too, it was in the first book, the Lafayette book, we had a lot of material here that had been collected for decades. And Mary teaches a little history class in the local schools. So she was very, very up on all of the information for that, but we didn't know anything about the tunnel. We couldn't get in. They would never have let us in to see the fourth bore building whatsoever. I mean, we were lucky to get an invitation to the opening, which you saw when you showed that photograph. But so it was really fun to do the research, but then with the Caldecott, with the fourth bore rather, it was hard to get photographs, and we finally got a connection with Caltrans because they had their own photographer that they hired, and he wouldn't let us use his photographs without paying him. So,
but there was an office. There was an office for Caltrans here in Lafayette, and a lovely woman named Ivy was in charge. I think she was their public information person, but she put us in touch with a lot of people, and we actually found somebody from Caltrans, I think, who read the technical parts that we wrote about that we still don't necessarily understand. But they were really, really supportive and helpful about the factual part of the books.
And I'll tell you something else about the research. So we thought, well, we should kind of know something about tunnels, right? So we went to the library, and they had things on the tunnel, and there was one on a tunnel in Switzerland or Germany or something, and a few other things. But it was either total geology or middle school books, which gave you enough information that you could be versant in the topic. And, other than that, there was kind of nothing in between.
Oh, you've got another fan club member. You guys need to start a club, I think. But they're curious. Vince is curious. Do you post information on where your talks will be?
Well, we haven't done a talk for quite a long
Yeah, the
time
book's been
because
out
of,
a few years.
because of the pandemic. We did one here. We did one out your way somewhere. It was at a church, I think, or something. I remember along when it first came out, but we really haven't done much talking about this recently for obvious reasons. But if
Might be
anybody's
time-
interested, let us know.
Might be time to take the show on the road again, I guess.
And the Caldecott tunnel is a true tunnel bored through rock, but like the Bart tunnel under the bay, that's a segmented tunnel where they took segments that linked and put each one down separately and then fastened it together with divers, and it's completely different. It's a tunnel, but it's not a true tunnel in the boring sense of the word.
And I think we're going to end on a
Okay.
Thomas Train question. So this was covering one of the jet fans, and Debbie's asking if you could see it, but it seemed to be a cover that was covering
Yes.
that would have been
Right.
for construction, correct?
It was covered for transport to the site.
If you go into the fourth bore now, as you drive in and look up, you can see those big fans are up
Yeah.
there. And they can blow either direction in case of a fire or something. They can take out the smoke or
And-
the fumes.
And since there's about a 4% grade in the tunnel, and there's generally westerly winds, the winds come in from the Oakland side and go up through the Orinda side. But in the tunnel fire, there were people that died that were closer to the exit on the Orinda side, but the smoke came up and got to them. And there were people that were much closer to the actual fire, but they were on the downhill side of it and they didn't get any smoke. And that was a problem in building the tunnel, because if it was windy like it's been this week, they had to have a curtain to stop the air flowing through. Otherwise, it was just a wind tunnel.
Okay. I drove through the tunnel yesterday, heading towards Oakland and then coming back. And I'm a lot like the people that responded this morning. I've now become a fan of the tunnel from what you told us in the last today and then at our practice session. I very much appreciate that site a lot more than I did before Tuesday when we did our first practice. So thank you very much.
Isn't it more fun? Isn't it more fun to drive through the fourth bore than it is coming through one or two coming home?
I love
It's
those
claustrophobic.
fans over top of you as you go
Yeah.
through.
We didn't discuss this either, but now all the bores are interconnected and they have all kinds of fire and safety equipment and sensors that they didn't have previously. So, and they say it's safer there in an earthquake than anywhere else.
Okay.
Well, thank you. And
Mr. Dunn.
we're sorry for the technical
no, it's
glitches, but
fabulous.
we're old women, so that's why.
No, this was fabulous. I enjoyed this very much. And I want to thank everybody for viewing this morning. If you missed any of our earlier programs, you can find them by visiting the museum's website at museumsrv.org. Today's program, as I said earlier, will appear early next week. Our next program will be on January 20th at 11:30. From 1913 to 1920, the SNA Studios built a production studio in Niles to take advantage of the area's beauty and great weather. The studio brought in multitudes of actors, directors, and stage crews to staff their westerns, romances, and comedies. Join Rita and Dave Pine, and I'm probably mispronouncing that, from the Niles SNA Film Museum to hear about the time that major motion pictures were filmed in the East Bay. If you like these programs and want them to continue, we ask that you make a donation by going to the museum's homepage, museumsrv.org, and clicking on the Donate Now button. The museum's also in need of volunteers. If you can give some time, please contact the museum. I hope you've enjoyed today's presentation. And on behalf of the museum, I'd like to wish everyone a happy holiday season. Stay safe. Thank you for watching.
Thank you.